load, because in power in the thermal power industry, the electricity loads it down. Inconsistency of machinery means the data have some safety issue. That's why the machine is not accessible easily. Manual analysis means the data they collect the data, but they analyze the data is manually. But in the form of a big data in the based on IoT, the manual analysis is not helpful for us. In IoT, the key point of the proposed model that make a different other as follow: in enable them to efficiently acquiring, process, and store real-time, scalable, and heterogeneous data from a distributed industrial environment. Means in the industry, the data is a very distributed form. PLC data is the PLC data have a different server. Vibration data have a different server. So I suggest that we collect the data from the common center point, collect from distribution system and collect from the common center point. By integrating the fleet-wide information of the sensor data, the data volume is reduced and use the part as a identity to get in the hidden knowledge from industrial big data. Improve the efficiency and reliability of the manufacturing industry by reducing the labor cost, energy cost, optimize the maintenance schedule. If we want to implement the IoT solution in the predictive maintenance, we follow the following step. First, we identify the equipment. Which equipment you want to the monitor. After that, we create a IoT-based platform. After creating the IoT-based platform, then we analyze monitor the data and give some basic analysis like a mean, mode, standard deviation, data behavior. After that, we use deep analytics like machine learning, use the artificial neural network, create the prediction model. After that, we create the smart control, and finally we create the user application. This is my proposed model. First, we identify the equipment and create the and generate the data generation and acquisition level. Here we get the data, turbine, fan, pump, and other equipment data is there. If you monitor the turbine vibration, then put the vibration equipment sensor. This is the device where the data is easily to access. And this is the field gateway, cloud gateway. Then we store the data in the big data warehouse. Here we perform the big data analytics, basic analytics, prepare the machine learning model, and check the machine learning model result. This result goes to the control application directly to give the sense to the turbine sensor like a equator sensor. And this is the user application. Here the user see the result, see the analysis result, see the prediction result, all other things. Thank you.
Mohammed sir.
Sorry?
I'm having one question.
Yes, sir.
You have done a very good presentation on this technique based on IoT. You are incorporating this technology with IoT. So do you check with what is the power constraint?
Power plant specs.
Okay. Hello, sir.
Hello, sir. I check the model in the power plant scenario. Okay, I collect the IoT based data based on OPC based on OPC server.
Okay.
And after that OPC server, we store the data from the different machine. The data is in text form. They convert the data into text form in the Excel format. After that, we check the result behavior, basic analytics, mean, mode, standard deviation, and control charts behavior also. The data.
And then what about the control chart, sir? You have told about control chart. It is only done with the Microsoft Excel or any other separate tool also you are using?
Sir, I'm using R.
Ah, okay, okay, fine. Okay, sir. Thank you. Thanks for your response.
Thank you, sir.
Chalu ma'am, you can proceed with the next paper.
Sure, sir, sure. Thank you, Mohammad Afaq. Next presentation is of paper ID is ICCTIM 277. Logo-based wearable textile antenna or for multi-band applications. Harvinder Kaur.
Thank you, ma'am. Host disabled participant screen sharing, ma'am.
Now you can share your screen also.
Okay, ma'am. Is it visible, ma'am?
Yes, now it's visible.
Okay, thank you. Good afternoon, everyone. Myself, Harvinder Kaur. I'm assistant professor in UIT Punjab University. I'm presenting my research on the logo-based wearable textile antenna for multi-band applications. So outline for this presentation is, so what are the wearable antennas? So with the increase in the requirement of monitoring and wearable computing, the wearable devices are coming, researches are being done vast in this field. So wearable devices, they can either fit in or outside the body. We can fit it or as a part of a clothing, as a non-part of clothing. We can use it as accessories or just human to human interaction. Means we can be wearable or body worn only. Okay? So various antennas are implemented inside the body also. So there are vast applications on the wearable antennas. Applications included the patient monitoring, wireless applications, defense application, robotics, indoor applications, biomedicals. So what exactly is this? How we are monitoring this through the wireless wearable antennas and or wearable devices. So if we are going for the sport performance monitoring, so heart rate check, want to check heart rate, sugar level, body temperature. So devices are, if they're attached on the body, so they can detect that performance and they can forward that data to the other communications, healthcare and the medical applications. So first one is the in-body. In-body, in that implant is done. So wireless implantable biosensors are added to this. On-body, the devices are attached to the body, off and on body. So communication is done. So off body is human to human or a human to base unit, what the communication is done, that is off body. On body, within on body networks, we are seeing that on clothing or on accessories, we are attaching some device which is detecting through the sensors and providing information to the outer world. In body is the implants. The implant antennas are the sensors are implanted inside the body. They are taking medical data from inside the body. So while designing this logo-based wearable antenna, textile antenna, some design considerations were considered while designing the specific dimensions and all the things of the antenna. So first of all, the width of the patch is calculated. Width of the patch is calculated by this equation in this free space. Dielectric constant of the substrate plays a major role. What is the value of that? In which rotated assumed frequency we are going to work on. If the width of the patch is smaller, then bandwidth and gain they are directly proportional to width of the antenna. That will also decrease if W is small. So if the frequencies are at high frequencies, the width, there is we have to take care of the bandwidth and it doesn't go that much high values. Calculations of the effective dielectric constant. These are the equations required to be used to calculate the dimensions of the antenna. So substrate dielectric constant, if we are going to work on the textile, in this presentation, I'm going to present the antenna on the wearable textile antenna. So textile is a substrate we are using. So textile, there are different type of researches has been done on the different textile materials. They use different textile materials, the cotton, they are dielectric constant, polyester, polycord, jeans, perfume. So I worked on the jeans. I compared earlier in few of my researches that comparison between 2-3 textile materials, how the results are coming from that. Jeans materials comes up to be best for the ISM bands and also I want to work on the ISM and the medical application. So material used for this proposed antenna design is the jeans is the substrate material. Jeans substrate material, their permittivity is 1.6, loss tangent is 0.00631. So these values are used for their calculations of the dimensions of the antenna. So patch and the ground, they are used as a copper tape, copper and nail material. After using that equations for the dimension consideration, design considerations, these are the values came out to be. So our working is done on this design, antenna designing is done on the 50 cross 80 cross 1.12 and 50 cross 80 cross 0.56 dimensions, millimeters per millimeter cube dimensions. So these are the width of the patch is taken 53.675 mm. So these are the dimensions. So 50 cross 80. So miniaturization thing is also taken thing because this is used as a wearable antenna. So they are using it as a part of a clothing. So if the antenna is so large, it is not comfortable to wear that thing. So thing is taken into mind that it should be very small in size, whatever the smallest possible thing we can do, that much is taken for this. So A-shaped wearable antenna, then we can use it as a logo for something. If we are using it for any accessories, so A word is used for that. So whatever the thing is different, A logo is used for any accessories or for your jeans material, for whatever the thing you are using for. This is the design front view and the back view. In the back view, the ground substrate, some etching of the slot and slot is done from the ground plane to get the desired frequency resonance. So this is simulated S11 values of the A shape. So this comparison is done between the S11 0.56 mm. This is the substrate thickness. Substrate is jeans materials, jeans textile materials. So 0.56 mm jeans thickness and 1.12 mm jeans thickness. If we compare the results between two, the values for the 1.12 mm is going better than 0.56 mm. So if we just want to, if we are going to design antenna just in like that, we're using 2 layers of the jeans material. If I design the antenna, this A-shaped antenna will work well in the ISM band and it is applicable for other wireless frequency bands also. But our requirement is always that antenna should be thin. If we are using 2-layer antenna, some air gap will be there, some losses more than will there. Practically, it will go like that. So main consideration that the minimum thickness we can go for, we should use that thickness only for the presentation, for our designing. So if we compare this S11 analysis for these two antennas, these in frequency HS is equal to 1.2 mm, then it is resonant 2.3, 4.4, 7.5 gigahertz. So many resonant frequencies they are giving. These are multi-band antennas. In 0.56, it resonates at 7.4 with this. So if we have to design antenna keeping in mind the 0.56 mm thickness only, then some changes have been done in the and modifications are done in the antenna design so that with 0.56 mm also we can get the best desired results. For that, truncation is done at A-shaped, at the patch of the antenna in the A-shaped antenna. Here HS is equal to 0.56 mm. So these are the dimensions of the patch antenna. So field line is also 2.1 mm. So these dimensions are very small, 24.01 patch and 53.67 mm. So this is the ground dimensions. Now these are the results for the antenna of the modified antenna, which is keeping just HS equal to 0.56 mm only. So at 2.45 10 minus 10. So antenna is resonating at 2.4 also, 3.9 also, 7.2 gigahertz also. So it is acting as exactly as that of 1.12 mm also, and our requirement is also fulfilled. So gain at 2.45 mm of the modified antenna is 3.8 dB, 5 GHz is also 3.8 dB. VSWR value is 1.88 at 2.4 mm. So it should be less than 2 only so that good matching impedance is done. For all the frequencies greater than 3 GHz, VSWR is less than C, so less than 2. So it fulfills our requirements. So what we conclude from this antenna design and the S11 characteristic analysis, result analysis? So rectangular textile patch antenna is represented, which operates at various wireless applications, for various wireless applications and medical application ISM band. Wearable logo textile antenna can be incorporated in cloth, because you were using a simple jeans material here, so it can be incorporated into the clothing. So antenna thickness with this H.12 mm, it for 1 and it resonates these different frequencies, and 0.56 mm, it resonates at 2.5 gigahertz, 3.9 gigahertz, and 0.2 gigahertz frequencies. So it is suitable for medical band, C band, Wi-Fi, and WiMAX applications. And these are references used for this. Thank you, sir. Any query?
You have done the very good presentation.
Thank you, sir.
I have some questions.
Yes, sir.
That is, you have done wearable textile antenna for multi-band operating frequency.
Yes, sir.
What is the operating frequency? So through your graph, I found that you working on the spectrum of 1 to 10 gigahertz.
Yes, sir, 1 to
10 gigahertz. So what is that particular band name? Which band you are using?
Sir, 2.45, so ISM band particularly, 2.4 to 2.48.
Okay, okay. And one more question, ma'am. The spectrum which you are using is not harmful to the human body, since it is a wearable antenna in and on body. So it is not harmful to the human body?
Sir, for that SAR value is taken into consideration here, yet I have not taken that value. Okay. So that is always taken into consideration. It is within the limits only.
Yes, yes. So when you go for these type of analysis, you have to done SAR, specific absorption rate. Okay.
Oh, yes, sir.
So whether you done this experimentation in CAD-FIGO or HFSS software, ma'am?
So CST.
Okay, good. Okay, ma'am. Thank you for your response.
Thank you, sir. Thank you, sir.
Now, ma'am, we can proceed for the next paper.
Yes, sir. Yes, sir. Sure. Next paper ID is ICCTIM 204. Paper title is Effects of Mathematical Study of COVID-19 Epidemic in India. Padam Bhushan Bora. Present. Padam Bhushan Bora, you can present your paper.
Okay, ma'am. Thank you. Am I audible?
Yes, you are audible.
Okay. Good evening, everyone. Title of my presentation is a mathematical model study of the COVID-19 epidemic in India. Here is the outline of my presentation. First, we give introduction, then we do formulation of the model, then we show the positivity of solutions, then we calculate the basic reproduction number, then we find the equilibrium points and do the stability analysis, and finally we do some numerical verification of results, and then conclusion. So, COVID-19 pandemic is the biggest threat that humanity is facing at this juncture. It originated in the Wuhan city of China and has now spread worldwide. The WHO declared a state of health emergency with an international dimension. As of now, the United States of America is the most affected country due to this pandemic in terms of casualty and number of people infected. The COVID-19 pandemic has had serious repercussions on the global economy, estimated at billions of dollars. Many companies have stopped, many have lost their jobs, and normal day-to-day life has come almost to an halt. Modeling is an integral part of the public health decisions made today. In the current study, an SR-type mathematical model is proposed. The model highlights the infection dynamics of the COVID-19 spread. Further, we perform stability analysis and calculate the basic reproduction number of our model. So here is the model formulation. So the compartmental model is proposed as shown in the schematic diagram here. The various symbols here means S is the compartment of susceptible population at time t. I denote the compartment of infected population at time t. Q denotes the compartment of quarantine population at time t. R is the compartment of recovered population at time t. Capital N, which is the sum of ASI, Q, and R, is the total population at time t. Capital Lambda is the per capita birth rate. Mu is the per capita death rate. Beta is the rate of infection. Gamma is the rate of quarantine, and theta is the recovery rate. So here is the model. And the model equation is described here. ds dt equals to lambda n minus beta si by n minus mu s. di dt equals to beta si over n minus gamma plus mu times I. Equity equals to gamma I minus theta plus mu times q. And di dt equals to theta q minus mu r. The initial conditions being S naught, I naught, Q naught, and R naught, where S plus I plus Q plus R equals to N. Now, if we do the normalization of the equation by dividing everything by N, then the equation, normalized equation becomes ds dt equals to lambda minus beta Si minus mu S, di dt equals to beta Si minus gamma plus Q times I, equity equals to, and so on. Here we have used the same symbols for this normalized part and the original part. And the initial conditions are S naught, I naught, Q naught, and R naught. But now S plus I plus Q plus R equals to 1. So here are some assumptions and implication of our model. Each of the compartment Si, Q, and R is assumed to be homogeneous with random encounters, and hence we are assuming the loss of mass section. Each individual in the I compartment are both infected and infectious at the same time. There is no latent period of infection. One becomes immune permanently after recovery from infection. Thus, once one is in our compartment, he stays there forever. The newborn joins the susceptible compartment as they lack immunity. Under the assumption that birth rate and death rate are equal, over the time period we are considering, the total population n remains constant. And this is so because the NDT is lambda minus mu, which is 0 if they are equal. Now we see the positivity of the solutions. After integrating the equations of the proposed model in the interval 0 to t, we get it equals to I0 times e power 0 to t, beta is zeta minus gamma minus mu times d zeta. And similarly for S, Q, and R. And since from each of the we can see that if the initial conditions are non-negative, then they all remain non-negative for all time t greater than equal to 0. Hence the model is positively invariant, which means that for given positive initial values, the solution always remain positive. This is essential for a realistic model. Now we find the basic reproduction number R naught. The basic reproduction number is defined as the number of secondary infection produced by the index case in an otherwise susceptible population. That is, R naught is given by rate of infection times average duration of infectiousness. We compute the basic reproduction number using the next generation matrix method. This is calculated as the spectral radius of the matrix FB inverse, where F is the incident matrix beta and V is the transfer matrix mu plus gamma here. Thus R naught is given by beta over mu plus gamma. Next we find the equilibrium points. We assume lambda equals to mu so that the total population n is constant. This in particular implies that it is sufficient to consider this equation for Si and Q only, since R is obtained from this equation of sum equals to 1. The fixed points of the system then are as follows. There are two fixed points we find. The first one is the disease-free equilibrium point, which is S equals to 1, I equal to 0, Q equal to 0. And this equilibrium point means that there is no COVID-19 pandemic. And this other equilibrium corresponds to the disease coexisting equilibrium point, which is E2, S equals to 1 by R naught, I equals to mu times R naught minus 1 by beta, Q equals to gamma Q times R naught minus 1 by beta times theta plus mu. Next, we do the stability analysis of the equilibrium points. To investigate the local stability of the biologically feasible equilibrium points, eigenvalue of the Jacobian matrix at the corresponding equilibrium points be determined. The Jacobian matrix of the system at the equilibrium point E1 is turned out to be this one, minus mu beta 0 minus beta 0, 0 beta minus gamma plus mu 0, 0 gamma minus theta plus mu. And the eigenvalues are lambda 1 equals to minus mu, which is negative, lambda 2 is beta minus gamma plus mu, lambda 3 is minus theta plus mu, which is also negative, because all the parameters are positive. So this pre-equilibrium will be stable if the second eigenvalue also is less than 0, that is beta is less than gamma plus mu, that is R naught less than 1. And similarly, it will be unstable if R naught is more than 1. And we do this stability analysis for the second point, equilibrium point. The Jacobian matrix of the system at that equilibrium point E2 is J2 equals to minus mu R naught minus beta by R naught 0, mu times R naught minus 1 0 0 and 0 gamma minus theta plus mu. The eigenvalue of the say lambda 2 1, lambda 2 2, and lambda 2 3. Lambda 2 3 we can find clearly from here, minus theta plus mu, which is divisibly less than 0. And from the Routh-Hurwitz criteria for the remaining eigenvalues, we get that the equilibrium point it will be stable if mu R naught is greater than 0 and beta mu times R0 minus 1 divided by R0 is greater than 0. Since all the parameters are positive, so this term is automatically greater than 0. So this translates to saying that this term is greater than 0, which is equivalent to saying that R0 minus 1 is greater than 0 or R0 is greater than 1 for the stability of E2. Similarly, the disease coexisting equilibrium point E2 will be unstable if R0 is less than 1. Thus, a bifurcation of the system occurs at R0 equals to 1, where the stability of the equilibrium point switches. Now we do some numerical verification of our results. We are assuming beta to be 0.5, gamma to be 0.49, theta to be 0.05, and mu to be 0.02. So here R0 is found to be 0.98. And since R0 is less than 1, and the equilibrium point E1 is ought to be stable, whereas U2 should be unstable. And as we can see from the figure also, that this S is represented by this red line. This remains at 1 for all time, and the rest all remains at 0 for all time. Thus, in this case, E1 is stable, verifying our theoretical result. Next, we do this for beta equal to 0.5, gamma equals to 0.24, theta equals to 0.05, and mu equals to 0.01. In this case, R0 turns out to be 2. Since R0 is greater than 1, this time the equilibrium point E1 should be unstable, whereas E2 should be stable. And as you can see from the figure also, that as a process should 1 by R0 equals to 0.5, which is shown by the red line here, and this 0.5 line is approached symptotically here. And similarly for IQ and IQ are also approached their respective values. Now we do a comparison for different quarantine rates, gamma. So in the first case, gamma is taken to be 0.24, and in the second case, gamma is taken to be 0.39, rest all parameters remaining the same. In the first case, we see that the red line which corresponds to the proportion of susceptible people population, this process 0.5, whereas in this case, this process around 0.8. So in the first case, when gamma was lower, we see that almost 50% of the people remains unaffected by the virus, whereas in the second case, when gamma is more, around 80% of the people remain uninfected by the virus. So we see the higher the quarantine rate, so better it is for the people. So in the come to conclusion and discussion, we have seen the importance of the basic reproduction number R0 in determining the course of the epidemic. In particular, we saw that there is no epidemic if R0 is less than 1, and there is an epidemic if R0 is greater than 1. We have also seen that a bifurcation occurs at R0 equals to 1 when the stable and unstable equilibrium switches. We have made the model realistic by incorporating the intervention of quarantine. We also saw that the higher the rate of quarantine, the epidemic is better dealt with. And there is further scope of improvement by taking into account actual data, which we plan to do. And these are the references for our work. Thank you for your attention.
Sir, you have did a very nice presentation.
Thank you.
Padma, sir.
Thank you, sir.
I have one small query. You have listed some statistical analysis. Do you check any computational complexity in your method?
So actually, I just use programming in R language here.
Okay, okay.
Yeah.
Numerical verification is good, sir. The test, the conditions and all you also gave very nicely. So you not checked about any complexity, number of complex, that is computational complexity. Okay, sir. In future, you can consider that also. It is a very good and a trendy method. Thanks for your response.
Thank you, sir.
Shalu ma'am, we can proceed with the next paper.
Yes, sir, sure, we can proceed. Next paper ID is ICC-TIM 270, a novel quartile deviation score evaluation method to minimize uncertainty in decision making. Paper author is Raman Kumar. Raman Kumar, you can present your paper.
Okay.
I have just one announcement. If anyone else want to present their paper, then tell me their name through chat box. Okay, now you can start, Raman Kumar.
Ma'am, this is the last paper or any more paper is there?
Sir, this is the last paper. If anyone give me the name in the chat box, then another paper may become.
Okay, okay.
Good afternoon, ma'am. Am I audible?
Yes, you are audible, but I think you have some network.
And screen is visible to all of you?
Yes, screen is also visible.
Shall I start?
Pardon?
Ma'am, shall I start?
Yes, you can start.
Experts. I'm giving a presentation on my paper submitted to the ICCTAM 2020 conference. The paper title is a novel quartile deviation score-based method to minimize uncertainty in the decision-making process. Yeah, as we all know, we have to take decision in our daily life, and similarly, the industry people also have to take decision in the daily life. And literature supports that there are so many decision-making method available to take a appropriate best decision to evaluate the alternates based on the criteria of attributes. In this work, we have tried to propose a new decision-making method. In literature, already there are numerous decision-making methods are available, such as AHP, analytical hierarchy process, Tops's method is there, Promethe, Electre, entropy weight, and fuzzy concept theory are available. In this, why we have choose this topic? Because the existing method have some drawback. We have tried to highlight that the limitations of the existing decision-making method and try to propose a new method. Abstract
Raman Kumar, your voice is not audible. You are mute.
Hello.
Hello.
Yeah, ma'am, am I audible?
Yes, now you are audible.
Yeah, the objective method is to provide the ranking to the alternate so that a decision maker can choose a better alternate. The existing method, there are some few downsides which I have listed here. If we implement two or more MADM tool, that is making tool on a same problem, that we could get the different ranking from the method. So again, maker is in dilemma. Result is to be choose for the best alternate in that case. And second one is there is most popular tool that is TOPS is one having more than 21,000 citation on this topic. And the ranking provided by this TOPS is also not reliable in all the cases. Why? Because the ranking provided by the negative separation measure and the positive separation measure is not identical. Then we have to believe on the value of relative closeness only. That could be a solution, but not a best solution for every problem. That's why we have proposed this new method for decision making. Here I am showing the validation of this proposed model in the solid waste management, because it's a society problem for all of us. And we have tried to compare the results of our proposed method with existing topsides, Prothme and other methods. This is a literature review. People, researchers have already implemented AHP, Viker, topsides, Delphi, Fuzzy, and so other tools on the problems of solid waste management to get the best alternate. And in this case, we have proposed new method XIV so that we can get the more better result. And these are the flow chart for work. The first 4 steps are common as in other group decision making tools. Identification of alternate and attributes, then screening of this using the expert opinion, then prepare a decision matrix which consists of the value of attributes as well as the alternates. Then in the next 4 steps are we are proposing here to find the deviation measure credential. Then we have to develop the deviation matrix which result in the deviation score. And on the basis of the value of deviation score, we can provide the ranking to the alternatives. Here we have choose one published example. Validation of QDGC method in a solid waste management. Koban et al. In 2018 proposed a problem of solid waste management, and the team implemented the topsides, Promethe and Promethe 2 method to find the result. We have tried to implement our proposed tool in the same matrix, and we observed that the ranking provided by our method is not identical as provided by the topsides method. Look at this table. If I show you the result, this one, the topsides method showed that the S4 is the best alternate, and as per Promethe also, the S4 is the best alternate. But as per our proposed method, QDSC is shown that the S1 is the best alternate. So this is again delimina. What we did, we have reduced the last 3 worst alternates 6, 7, 8, because all the methods are showing that they are not in the top 5 category. So we have again developed the modify matrix and implemented all the 3 tools again on this matrix, QDSC, topsides, and the Promethe. And we have observed that now all the tools are showing that S1 is the best alternates. This is again, we have implemented the all 3 tools again, and now you can see that the topsides method as well as the QDSC method both are showing that S1 is the best alternate, not the S4 is the best alternate. This is at the rank 2. In the previous, the topsides method was showing that S4 is the best alternate. But as a researcher, we think that the ranking of alternates cannot be changed if we drop the worst element. So from this, we have taken this idea and proposed this method. In this method, we have proposed 2 equations, which are for the beneficial attributes. Second one is for the non-beneficial, where the lower value of the attribute is required, and for beneficial, where the higher value is required, like performance, profit. For non-beneficial, like cost, running cost, where the lower value is preferable. And similarly, results and discussion results of topsides and Prothme were identical, but not similar with the proposed method. So we implement the 3 method again on the modified table and compare the result and try to prove that the QDC method is validate and provide the more better result, reliable result. Conclusion: in this present study proposed MCDM method to enhance the decision making in everybody life and the industry people as well. And in this we have proposed 2 methods to publish method. and results are compared with the existing method. The limitation of this work is that we have not yet apply the fuzzy QDIC method for this, and we can also use some other method and can combine with this to make a hybrid method so that we can avoid the uncertainties and decision-making method. And we acknowledge the Copyright Office of Government of India for registering this concept under the ROC. This thing, this concept is already, we have taken the copyright, and this is a reference we have used in this. This is thank you. This is up to my part. Yeah, you may ask any query if do you have.
Is there anyone have any can ask from Raman Kumar? Professor Martin? Okay. Thank you, Raman. Thank you so much.
Okay, thank you, ma'am.
Is there anyone else who wants to present their paper? Who wants to present their paper? Okay. Now I call to Professor Martin to conclude this session. Professor Martin.
Can you hear my voice?
Yes, sir. Yes, sir. Now we will.
I will conclude this session. I thank to all participants and researchers who have gave their research presentation in this reputed international conference on computational techniques and intelligent mission 2020. And once again, I thank you all the management staff for Baba Farid College Punjab for this nice opportunity for me as a keynote speaker and a session chair. Yesterday also I have done, and I also personally thank to Professor Meghachand sir for his kindness and invitation. And also I would collaborate in future programs and research. And also I thank to Professor Shalu Gupta ma'am as coordinated well, and he done MC very nicely for this session. Thank you once again for this wonderful opportunity. We will meet in the future upcoming programs.
Thank you, Professor Martin. Thank you so much.
Yes.
Now I will present the report on international conference. Please, sir, Martin, give me your views also about the conference.
Yes, actually, this conference is very nicely organized by organizing committee. I thank to all organizing committee, technical committee, and also this conference for 3 days from 26, 27, 28. All organizing committee has been very nicely and patiently done, and across the global many keynote speaker and then participant came, and as Meghachand sir also repeatedly give input to WhatsApp, and he will call about this conference, and I have very much thank to him. He gives some inputs regarding to this conference. He not only his team, entire team has been worked nicely for this conference. Once again, I will thank to him, and in future also he and his team has to continue like this for his success. Thank you.
Thank you so much, sir. Now, Professor Ada Ali, do you want to share some views? Professor Ada Ali? Anyone else who wants to give their views regarding conference? Okay, now I will give the report. I will present the report on International Conference on Computational Techniques and Intelligent Machine. Respected Principal Sir, Pradeep Koda, Professor Dr. Manish Bansal, and coordinators Mrs. Monica and Manish Jindal Sir, all the members of the organizing committee, ICCTIM, national and international, and all dear delegates from all around the world. It's a great matter of pleasure that Baba Farid College has organized International Conference on Computational Techniques and Intelligent Machines. ICCTIM 2020 is a premier international forum for researchers, practitioners, and educators to present and discuss the most recent innovations, trends, and concerns, as well as practical challenges encountered and solutions adopted in the fields of computational techniques and intelligent machines. This conference aimed to bring together researchers around the world to exchange their research results and address open issues in all aspects of computational techniques and intelligent machines. ICCTIM 2020 is an outstanding platform to discuss the key findings, exchanging novel ideas, listening to the world-class leaders, and sharing experiences with peer groups. It provided the opportunities of collaboration with the international and national organizations of repute to research community of Baba Farid College. In this conference, opening address is done by Mrs. Shifali, Assistant Professor from Department of Mathematics, and welcome address by Principal Sir Dr. Pradeep Koda. And about the conference, Dr. Mehrchand, who is organizing secretary of this conference, and guest of honor is Valentina ma'am, and chief guest is Professor Dumitru Bilianu, and vote of thanks is given by Dr. Manish Gupta, who is research head of BFGI. In this, we have totally 14 sessions are there. In the first session, plenary talk is given by Professor Valentina, and invited talk is given by Professor J. Jenkin Winston, and the theme of first session is Advances in Computational Intelligence and its Application. Then second session, which is going on parallelly on 26th November, and the theme of this session is Innovative Techniques and Applications in the Field of Mathematical Modeling, Biomathematics, and Computational Techniques in Sciences. And in this, plenary talk is given by Professor Dumitru Bilianu and chaired by Professor Shilpi Jain, and invited talk by Professor Shilpi Jain. In the third session, the theme of the session is Advances in Computational Intelligence and its Application, and plenary talk is given by Professor Anand Nayyar, and this session is chaired by Professor Ranveer Singh Bhatt. Session 4, which is also held on 26th November, theme of this session is Innovative Techniques and its Applications in the Field of Mathematical Modeling, Biomathematics, and Computational Techniques in Sciences. And the plenary talk is given by Professor Praveen Agarwal, and invited talk is given by Bonia and chaired by Professor Mehrchand sir. And session 5th is organized on 27th November, and the theme of this session is Advances in Ambient Intelligence and its Application. And plenary talk in this session is given by Professor Lalit Garg, and session is chaired by Professor Yumna Janta, and invited talk is also given by them. On session 6, the theme of this session is Innovative Techniques and its Applications in the Field of Mathematical Modeling, Biomathematics, and Computational Techniques in Sciences. And plenary talk is given by Satyabir Singh, and the session is chaired by Professor Martin Sagyam, and invited talk is also given by them. And session is chaired by Dr. Narinder Singh. 27th November, the session 7th is chaired by Professor Anand Nayyar, and the theme of this session is Advances in Ambient Intelligence and its Applications. and inverter talk is given by Professor Anupam Yadav. Session 8, which is held on 27th November, and the theme of this session is Innovative Techniques and its Applications in the Field of Mathematical Modeling, Biomathematics, and Computational Techniques in Sciences. And the inverter talk is given by Professor Ojan Ozer, and the session is chaired by Dr. Meherchand. Session 9, which is held on second day of the conference, the theme of this session is Advancement in Computational Modeling and its Applications in Education, Health, and Social Care Management. And session is chaired by Professor Sandeep Kumar, and plenary talk is given by Professor Gagangeet Singh Ojla. And session 10th, which is also held on second day of the conference, the theme of this session is Advancement in Computational Modeling and its Applications in Education, Health, and Social Care Management. In this, the session is chaired by Professor Hamid Dei and co-chaired by Professor Sukhpreet Kaur. And plenary talk is given by Zakia Ma'am and Professor Hamid. Session 13, which is held today on the theme Advancement in Sustainable Engineering and Automation and its Application. This session is chaired by Ikram Raja Khan, and plenary talk is given by Professor L. Arun Raj. Session 14. The theme of this session is Advancement in Sustainable Engineering and Automation and its Applications. The session is chaired by Professor Martin and co-chaired by Professor Shinu, and plenary talk is given by Ranbir. In this conference, there are more than 155 research papers received for the conference, out of which 85 papers are accepted for the conference. 70 papers has been presented in this conference, and rest we get according to their presentation. As many participants facing the network issues, so there are totally 70 papers are presented in this conference, and rest of the papers are not presented, and recording of these are done. The entire plenary and invited speakers was present here to present their valuable thought. Overall, this conference accomplished with grand successfully. To make any event successful, a strong team always is there. Even member of a program committee played very important role. Members of the committee are Professor Gurpreet Singh, Dr. Shalu, Mukesh Garg, coordinators Ms. Monica Goyal ma'am and Manish Jindal sir. As the conference was on virtual mode, how we can forget role of technicians involved in the committee? Mr. Talvinder Singh, Gurmeet Singh, and Mr. Bharat Gupta was always support day and night to handle all type of technical issues. At the end, on behalf of the program secretary, I congratulate to BFCI. Thanks to all the supporting members, and thank you to Martin sir and all the plenary and inverter talk speakers. Thanks to all. Thank you, sir. Is there anyone else who wants to give their views? Okay, thank you. Thank you so much.
Thank you, ma'am. Thank you, sir.
Thank you. Okay.